Okay, so a few announcements before we ask our mining engineering panel to step forward. So there's going to be a gift at the end of the session. So at the end of the entire program, around 1600 hours. So if everyone could just wait until then to receive the gift, that would be amazing. There's also an internship opportunity that will be announced at the end of the program. So please stay for that so that you guys can know. One of you guys will be able, or two or whatever, you'll be able to get an opportunity to do an internship. So you can just wait for that announcement as well. And we're also going to give out gifts for the South African Symposium that will be happening in October. So if you guys want to get all of that information, please wait until the end of the session. Okay, so now we will invite over our mining engineering panel. Or let me just give it 2 minutes for everyone to settle down. Okay. Okay, so now we are going to get our mining engineering panel participant, Dr. Barakos. And he is the research doctor at the Technical University of Bergakademie, Freiberg, and Dr. Kanan from Azerbaijan. Also, please welcome Ms. Monet, is a PhD candidate and scientist from the Technical University of Freiberg. Oh, sorry. Kindly, because we're sharing a mic, kindly use the sanitizer provided. And okay, we will start with Dr. Barakos.
Thank you. Hello, everyone. It's a great pleasure to be here for a second time. I was here last year for the first engineering symposium, and I have to say that this is a big increase. And I would like once more to thank Anwar and his team for doing that great symposium. So please join me. Big clap to all the team. I've been to nearly 100 conferences around the world. I even have organized some of them, and I know how difficult it is, even at the very, very last moment, to organize it. So they have done an amazing work. Now, you're here about the mining engineering panel. You'll see different panels. You'll see different engineers from every kind of discipline. So we are going to talk here about mining, but I'm going to be motivated by Parviz and try to motivate you for the engineering part, not going to technical details about mining, okay? And we are going to talk about the education and lifelong training of future mining engineers. So maybe, I don't know if Igor has already gone, I will try to talk about digitalization as well, so cover him a little bit as well. Okay, so what do you think a mining engineer is? I had that question last year, but let's wrap it up a little bit more. What is your thinking when you hear of a mining engineer? First of all, this is one of the explanations. It had to be an academically accomplished person in the engineering discipline of the extraction of minerals and metals from underground, from underneath the ground, above the ground, or in it. But what is the first picture that comes to your mind when you hear about mining engineering, a miner, a mining engineer? Maybe it's that one. Yeah? A dirty person coming just out of a very, very dark, cold, or very stressful environment. Or even something like that. Yeah, you could be right, but that was many, many years ago. Your grandparents, your fathers maybe, but not anymore. What is an engineer, a mining engineer today? I would say it's mostly something like that. Management, engineering, using machines, using technology, using the art, the state-of-the-art technology to excavate, to bring minerals and metals out of the earth. Or what I prefer to say, my colleagues from Freiberg, using robots, going underground. Of course, you have to go underground or on a surface mine pit. You have to put mud on your boots. You have to dirty your clothes, but not like in the past. And what is changing today? We will talk about how mining has been done today. I'm also waiting for the presentation from Azerbaijan later on. It will be very, very interesting. What's happening with mining nowadays? We have been mining for centuries, for thousands of years, I would say, for minerals, for metals. So almost all of the surface deposits have been depleted, have gone. Only low grades, difficult. So what we have to do, we have to go very deep underground. We have to go in very, very remote places. Parviz said for going to almost 8 hours from Moscow on the north of Japan, or in Abu Dhabi, or in Libya, in 52 degrees, in the middle of the desert, just to take oil out. The same comes with mining. You may have to go 4,000 meters deep down the earth in South Africa to be able to mine for diamonds. Or you have to go in very, very remote places in Canada, in northern Canada, with minus 50 degrees. Or in order to be able to have supplies, you have to wait until the very big winter so that the lakes are frozen, and then trucks could drive over them in order to bring supplies to the mines. So grades are also getting lower, increase in environmental restrictions. You're hearing about the green economy, social license to operate, and so on. So the nature of job in mining is also changing. What do we need? We need automation, we need robotics, we need mechatronics, we need remote mining. So maybe the engineer is sitting somewhere on the surface or even in a very comfortable office and mine remotely by using technology. In situ mining or partial in situ mining. Real-time monitoring, the temperature, the gases, the environment, everything that comes to improve the health and safety of the people that are working in these environments. And also the ability to require large amount of data. You have heard about the Internet of Things, about data, about everything. That is coming to the mining industry as well, to the petroleum industry as well, to the mechanical engineering, chemical engineering. So this is something, some of these terms, you will hear them all day in different disciplines. And that shows how these disciplines are interconnected. An engineer, in general, is someone that finds solutions and thinks outside of the box. The technical details are changing in each discipline, but there are some basic abilities that each engineer has to have. And you will find some of them also in mining engineering. So this is kind of the future, or maybe not the future, even the present. You can see from the Sandvik test mine, the heart of digitalization today about mining, somewhere in Finland. It's a very, very strict place. Not many people can visit it yet, but they're in the up-to-date technology when it comes to mining. Or digitalization, or you see, now the mining engineer is using a tablet. He's not digging with his hands. He's using a tablet, guiding a machine, sitting comfortable, or even using of robots underground. And why is that happening? Most of you here are born, like I would say, after 2000. Who is born after 2000? Let's raise hands. 1999, I would say. Anyhow, you may have heard that you belong to the millennials, or even the X generation, the very next generation. And the millennials will be occupying in 5 years 75% of the workforce. What does that mean? You've all seen small children using tablets today. I was surprised the other day that a 3-year-old child took my mobile phone. She could memorize the code that I have put just 2 minutes ago, found the application for the camera, turned the camera to a selfie, and started posing and making selfies. So it's crazy how young children, young generations, are very, very easy, very keen in using these digital tools. And this is why in the mining engineering or the general engineering industry, we have to bring these devices, make everything digital, give a motivation for these people to work in the digital, in the mining engineering industry, in the petroleum engineering industry, and so on. Even virtual reality. It's easier for a young person to use it than an old person. You cannot teach an old dog new tricks. That's a saying that is almost in every country. But it's easier to have young students, young children, to do that. So what is happening with training and education nowadays, or what should be happening at least in more countries, or in all countries? We do have the theoretical education. We have laboratory scale training in the schools, in the universities. We are using even exemplified software for making block models, for making mining plans on the computer screen before even going underground. And as I said, virtual reality, augmented reality, visit of rooms, trying to find, to understand the sense. Even better, visit internships or certain, short excursions or visits into actual mine sites, into processing plants. But these are always short, stressful, not enough. And let's go now see each part. Now, there was a talk in the first panel that they talked, Parviz, you said that your first teacher was a 90-year-old guy that was barely trying to reach the podium to speak. And I guess that he was using these advanced technologies, either a blackboard or even that. Yes? Well, guys, forget about this. Don't use anymore. What are we using today? Multi-screen classrooms, classrooms with computers where you can interact online. Some applications for endorsing students and making them interact with the teachers during the courses, answering questions and so on. Even better, as I said, classes with augmented reality, with virtual reality, trying to understand what is the size of a loader, of a truck, how does a machine work, how do you see it, how do you prepare an explosion, and so on. When it comes to training to professionals as well, lifelong learning, doesn't mean that when you're ending the university that you're done, you have achieved your goals, you are now completely wiseful engineers, and that you can work for the rest of the your life with that knowledge. No, forget about it. We are shifting now from the industry to the digital technology. So you have to learn new things, and you have to keep on learning probably the whole of your life. So these are old engineers being trained either in a virtual reality room or with augmented reality. So lifelong training will keep for the rest of your life. Now, we said about theoretical education. Using of software, making plans of surface, of underground, going in laboratory scaling, using sensors, using robots, using state-of-the-art technology to simulate everything in a laboratory scale. And of course, turning that to underground testing mines, testing robots, students using tablets underground with a Wi-Fi connection. I've been to 3 mines deeper than 1.5 kilometers, and they all had Wi-Fi. I even tweeted saying, oh wow, I'm tweeting now with a Wi-Fi from 1.5 kilometers down the earth. Some of my friends didn't believe me, but then I also put a photo. Teaching of operators in a safe environment first, and later going to a mine. Or even in front of multiple screens, simulating how a driver seat of an operating machine would look like. And here we go to the skills that you need to be having. That might be a scary slide, but don't be afraid. So, what is expected for you to be in the future? T-shaped engineers. And what does that mean, T-shaped? You understand, everyone understands the shape of the letter T. So meaning that you have to have a broad sense of skills, that is the horizontal part of the letter T, and then a vertical one, that means that you have to be more skilled, more in-depth knowledge in one specific discipline. So you have to know good English, or good Azerbaijanis, or English enough for you to be able to go internationally and work. Know about safety. Even though you're requested to be mining engineers, know the basic about structural geology, to be able to understand what is a granite, what is a sand, what is sandstone, and so on. Mathematics and statistics, and logistics as well. You don't have to go very, very much in depth, but you have to know some basic things in order to communicate or understand or evolve. Mine asset and management, mine finance and evaluation, and of course knowing the laws, the mining laws of the country that you are. And we keep on going now to the technical skills. Some of them or all of them may be in depth. Mining design, automation or robots or digital technology, ventilation and services for the health and safety underground, rock mechanics, how to close a mine in environmental terms, rehabilitation, processing. Even a mining engineer should know how processing works. What is the capacity of the processing, so that he knows how much tons he can produce. So have an interaction and interconnection of all parts of the mining cycle. Instrumentation as well. And when it comes to soft skills, each mining engineer should be a management engineer. Each petroleum engineer should be the same. All of engineers. Communication relations. Be able to communicate, be able to talk, go in conferences, elaborate, communicate, make international contacts. Sustainability. Risk management as well. You have to know the risks. First of all, for the health and safety of all the people that are working inside the mine. Social responsibility. Mining doesn't have to do, or safety doesn't have to do only with the people that are inside the mine, but with the surrounding environment, with the local societies, with the broader society. In our days, you may have experienced a lot of arguments when it comes to mining, but mining is the primary source of all the high technology goods that we're having. In order to have this screen, we need some precious metals for being able to supply lead, colors, and everything. In order to have this, we need precious metals. These all come from the earth. So we need mining. But what do we need in mining? We need sustainably and environmental mining, and socially acceptable. Cultural awareness. It's much, much different to mine in Azerbaijan, to mine in Africa, or Australia or Canada. So wherever you are, you have to know the cultural awareness and adjust. And of course, the global experience. Now, as I said, this may be a little bit scary, but these all come in practice. It doesn't mean that when you get your diplomas, you'll be ready. But this will be coming with lifelong learning experience. More field work, be able to communicate. These are the tips for you to take home. And have diversity of ideas. And of course, motivation. With that, I would like to thank you. I think that we're going to have questions at the very end. Yes? Thank you.